Two particles undergo SHM or in SHM in a straight line about the same equilibrium position. Amplitude A and time period t of both the particles are equal. At time t is equal to 0, one particle is at displacement y1 is equal to plus c. We will take it as x1 is equal to plus c also. The other is at x2 is equal to minus a by 2. And they are approaching towards each other. After what time they cross each other? So now if this is the line along which they are moving to and fro, and this is the main position, first particle is at plus a position and moving towards main position. Second particle is at minus a by 2 position and it is also moving towards main position. So the question asked is where will they meet? So we shall solve this problem by using the circle method here. The circle, first particle is at extreme position. We will take y-axis as reference axis here, and second particle is at position minus a by 2. That means over here. The second particle is moving towards main position. That means for this, if I draw a particle over here, so here the particle is moving along the circle like this. Okay. Now the first particle has to move down like this. Okay. So now we have to find out where will they meet. After how much time they will meet here. Okay. First of all, we will find out the initial angle made by the second particle here. So this one is first particle and this one is second particle. So let me draw a line from origin to the second particle here. So let this angle can be taken as, for example, theta here, angle is theta. So this value is a by 2. So here also angle will be theta only. So first of all, I will get the angle as, so let me use sine theta. Sine theta is equal to, and the length of this radius can be taken as capital A by 2 by capital E, which is equal to 1 by 2. So that means angle theta is equal to 30 degrees. So that means this particle, so this angle is 30 degrees now, 30 degrees. Okay. So now the particle is moving along the circle like this. At the same time, first particle is moving down like this. Okay. So let me imagine that if the second particle is over here, first particle reaching this position now. So means I can say that no, along this line they will intersect. Okay. So now we have to find out the angle here. So let me draw lines from the center, joining the particles 1 and 2 now. So let me imagine here the angle is 90 degrees. So let me imagine here the angle is alpha degrees, alpha here. Here the angle is again alpha here, alpha. So this angle becomes 90 minus alpha here. Here also the angle becomes 90 minus alpha. Okay. So first of all, the angle turned by the first particle from here to here is alpha. Angle turned by first particle is alpha here. Okay. So angle turned by first particle is equal to alpha. Okay. Next, angle turned by second particle now. Second particle is moving from here to here now. So the angle turned is first of all 30 plus again 90 minus alpha here. Okay. Angle turned by second particle till it reaches that position is equal to 30 plus 90 minus alpha. 30 plus 90 degrees minus alpha. So since these two angles are equal, I can take now alpha is equal to 30 plus 90, 120 degrees minus alpha. So from this I will be getting 2 alpha is equal to 120 degrees. Alpha is equal to 60 degrees. So 60 degrees means pi by 3. That means angle turned by particle 1 till from here to here is 60 degrees. That means I can equate now 60 degrees is equal to which is equal to pi by 3, which can be equated to omega t because angle turned is going to be omega t here. So pi by 3 is equal to omega formula is 2 pi by capital T into small t. So here pi is cancelled. I'll get now t is equal to small t is equal to capital T by 6. That means after t by 6 seconds they will meet.